Really?
Okay. So yesterday, well, let's do a problem of the day first. Let's do a problem of the day. This is a non-calculator question. It is. What? Why? MBT. Yeah, this is a mean value theorem problem. So here's what they're trying to trip people up on, just so we can be clear. Okay, so they're trying to fool people into thinking that this is an increasing function because it kind of looks like it is. It keeps going up and up and up. In which case you might think there's no critical points, but just because they show you certain values of a function and they happen to be increasing like this doesn't necessarily mean that it doesn't in between like do something weird, right? So that's why this one isn't true. Why this one isn't true, same reason. It might do something weird in between. That's also the reason why this is not true, right? Just because it appears as if the distance between these two is 28. The distance between these two is 12. The distance between these two is 6. So it kind of looks like it's getting less and less steep. But again, it might do some weird stuff in between. We don't really know. And that's the reason he's not true also. Any questions? Pretty easy question, I think. Another thing you should notice about all these questions I'm giving you for questions of the day is there's 5 choices. On the current format of the AP exam, there's only 4 choices. It's actually better for you. They changed that 2 years ago. They did some research and found out it was like a gender equity thing. They used to have 5 choices, and if you guess wrong, you got a question wrong, you got a percentage of a point taken off, like 25% of a point taken off. So for every 4 questions you got wrong, it negated one of the questions that you got right. Get what I'm saying? And they did some research and figured out that boys were more likely to take a risk and guess if they didn't know, and it was paying off for them because they could narrow it down to 3 choices and then guess and get it right. And so just to avoid that gender equity thing, they decided to not take off points for wrong guesses and also to have fewer choices. So it's actually like a win for everybody. All right. So yesterday we were talking about sketching slope fields. Any questions about that? So there's basically 3 things you need to be able to do. You need to be able to sketch a slope field if they give you a differential equation. You need to be able to solve a multiple choice question where they give you a slope field and ask which differential equation goes with it. And you have to be able to solve a multiple choice question where they give you a differential equation and multiple slope fields, and you have to pick the one that goes with the differential equation. So in all those cases, the things you should look for are points where the differential equation equals 0, points where the differential equation is undefined, and then other like patterns that you might notice, like for example, if x and y are equal, does something happen, or whatever. Like if it's a fraction like y over x, then when x and y are equal, it's 1, and so on. Okay, so today I just want to talk just for a few minutes about reasoning using slope fields, which is basically like questions you might see that aren't of those types that I just described that involve slope fields. And then I'll give you time to do your work because the homework's kind of long tonight. So, so I have some slope fields that I literally just searched for slope fields on the internet. Got some pictures. So I'm gonna put them up on the board, talk about the types of questions that you'll see. So the first type of question that you might see is they might give you a slope field like this and say, they might give you a slope field like this and ask you to sketch a particular solution that goes through a point that they designate. Like for example, they might say something like, find or sketch f of x where f of 0 equals 3. I don't know why it's turned out like weird. Whatever. All right, so if we wanted to sketch the curve that goes through the point 0, 3, all you do is you just start at the point 0, 3. Like, let's just say these are all integers. It's not really labeled properly, but whatever. So you just start there, and then you just like follow the contours wherever it might take you. So the best strategy, I think, is to kind of try and stay between the lines. Like just try not to intersect any of the little slope field lines. Or if you do, just have it be like parallel to it, like go right along it. So just try and stay between the lines. I mean, just kind of go like that. That's kind of the best strategy. And then this one kind of just go like that. So this kind of looks like a parabola. Okay. Another question that they might ask you, and by the way, like if they give you a different point, like suppose they said, I don't know why this is, but whatever. Suppose they said f of 1 equals -2 or something like that. So now you have 1, -2, that's like over here. It's the same type of thing, right? But our equations, our solution curve is going to look a lot different. Go this way instead of that, right? So depending on the initial condition that they gave you, the solution curve might have a different shape altogether, right? The second question they might ask you then is they might say, what's the range of the particular solution that passes through the point 0, 3? Does that make sense? So in this case, you can just tell from the curve that I've drawn here that its range is going to be all y values greater than or equal to 3. Does that make sense? Because it's a parabola whose vertex is at 0, or 0, 3 rather. So that's another question they might ask. What's the domain or range of a particular solution? And a lot of times you can tell just by sketching it into the slope field, you can tell what its domain or range will be. Let's do another example. Okay, so like this one, like if they gave us a particular solution, if they wanted us to sketch the particular solution that passes through this point right here, for example. So it would kind of go like this, right? Look like that, right? But if we wanted to sketch the particular solution that passes through this point, it would look way different. It would kind of go like this. And see, they both have asymptotes, the same asymptote, like diagonal asymptote, but they have way different shapes, okay? So you just have to be able to follow the contour lines. Does everybody get what I'm saying here? Kind of an easy concept. You're just sort of following the lines. So in this case, if this was the slope field, and if we wanted it to pass through this point, for example, it would kind of go like this, and you can kind of see it's asymptotic. Maybe not asymptotic, but that. So you might kind of go like that. Okay, but if it was a solution that passed through this point, it'd be a different shape. These solutions are definitely not like vertical translations of one another. Okay, that's the thing that you should understand. Now, at the beginning, when we first started talking about derivatives, we said if two functions have the same derivative, then they're vertical translations of each other. Why isn't that true here? Or the previous example, but it was true before. How can you possibly have two functions that have the same derivative that aren't vertical translations of each other? Interesting question. The difference is that if the solutions aren't going to be vertical translations of each other, like in this case, this is a slope field of a differential equation that contains both x's and y's. If you have a slope field that only contains x's, then at every x value, you're going to have the same derivative, right? So I don't know if I have an example like that here, but just think about it. Like if the slope field, or if the differential equation was dy dx equals x squared or something like that, then everywhere where x equals 2, you're going to have a slope of 4. It's going to look like just a slope of 4 all the way going up at x equals 2, right? Everywhere where x is 0, it's going to be 0 all the way going up. Everywhere where x is -5, it's going to be a slope of 25 going all the way up, right? So it makes sense that if you drew any solution curve, it's going to have the same shape. It's going to be that cubic function. It's just a vertical translation of itself. But if you have both x's and y's, that's when the slopes can be changing. Okay, so that's when your differential equations can give you a slope field like this. All right, so something like this. This is where it messes people up at times. Like, what if they said something like, find the range of the solution that passes through 0, 2. Okay, solution that passes through 0, 2. So here's the mistake that people make. They're like, oh, it's a circle. It kind of looks like a circle, right? The solution should be a circle. But it actually isn't. The solution here is actually just a semicircle. It has to stop at that point. When the tangent lines are non-existent, right, or vertical, like along the x-axis here, this particular solution has to stop at that point. Another thing you should think about is solutions to differential equations are functions. So you can't have it be a circle. It has to be part of a circle, a part that's a function, either the upper semicircle or the lower semicircle. So if the question was, what's the range of the function that's this particular solution to this differential equation, you'd say the range is all the y values between 0 and 2. That would be its range. Does that make sense? So that messes people up sometimes. They're just following the curve.
Would 0 be included in the range or no?
Yeah, because if you have an upper semicircle, like, for example, y equals the square root of like 4 minus, if the radius is 2, 4 minus x squared, right? 0 is definitely in the domain of this function, so 0 definitely works, right? And if I had the solution that includes -2, it would also include 0. Okay. By the way, I got this just by taking x squared plus y squared equals 4, which is the circle centered at the origin of radius 2. And I solved for y. Let's see if I have any other weird examples. Here's one that's kind of interesting, because if you have a point that's up here and you wanted to draw its solution, it would kind of look like this. But if you had a point that was like down here and you wanted to draw its solution, it would kind of look like this. Again, like totally different shapes. Okay? What do you notice about this slope field? Anything interesting about it or no? It kind of looks like that. This is actually called the logistic function, but in the middle here, it kind of looks like an inverse tangent function, right? It goes like this. It would kind of look something like that. A solution that's in this middle part. A solution that's up here would kind of look almost like exponential. It would kind of go like that, right? So what I want you to notice about this is that there's a horizontal asymptote. So if they asked you a question about the range or whatever of this function, it sort of depends on where you're at. Again, this is not very well labeled. I just copied it off the internet. So The range of this middle part would just be from here to here. It wouldn't continue past that horizontal asymptote. So when you're trying to sketch solutions from a slope field, make sure you notice vertical or horizontal asymptotes that are indicated by the slope field. Yeah, here. That was it. Okay, so I mean, that's basically what you need to be able to do, is take a slope field and sketch a particular solution based on that. The homework tonight is actually 3 complete free response questions that deal with slope fields. So the questions all involve sketching a slope field, which is super easy in my opinion, finding a particular solution to the differential equation that's given by the slope field, which we've done, right? That's just the separation of variables, integrating, finding the value of C, and then solving for Y. And then some other question. So that's kind of the part that I'm interested in mostly, but I want you to get more practice with the other types as well. So the homework is on Google Classroom, it's posted, and you can work on it right now. You can work together. We can work as a class if you think that's helpful to you, but I think it might be better for you to try it on your own. And then that's all we're doing for the rest of the period. So for 20 minutes. Remember, like, free response questions are designed to take about 20 minutes. So these questions I think take a little bit less time, but I think an hour of homework is too much for any class. I'm not going to give you an hour worth of homework, but yeah, I'll post it up on the board here if you want. You don't have to get it out of your computer or whatever. So for problems, like for the actual sketching the slope field part of the problems, just reproduce this on paper. The 9 points they're talking about would just be like the points that they've indicated on paper. So these are, like I said, these are complete 9-point questions. So I think that the differential equation questions on the free response part are maybe the easiest ones, and also they take the least amount of time, so you can save time for other questions. Actually, be tested. Stop recording.